Now, continuing from the concept of stress is proportional to the strain, so let's understand, identify what are the deformations and correlated to this expression. So we have types of deformation. Number one, in one dimension, length. For the shear modulus, is a case of changing the shapes. And term shear is actually a reference to similarities or analogous to cutting. While the last one will be the volume. Now, the term stress earlier, stress represent what we call as pressure. In the case stress, in the case that occurred changes information in terms of the length, we find that there are two types of stress. That it could be tensile, but it could as well be compressed. It's not here yet, but we're going to look at it later. So the term stress is originated from the word tension. Tensile tension. Stress, sorry, not the stress. Tensile originates from the same words as tension, tense. So since it's under tension, we would have later identify where does it undergoes tension. In the case of the second one, which is changing of the area, we have noticed that the term stress is as well applied over here, but the name is a little bit different. We call it as shear stress. And the last one is, however, a bit different, because now we are talking about volume, and to change a volume, there must be a force applied in all direction. Therefore, you find that the term stress now, just a little bit of modification that we would note it as changes in pressure. Now, the second one is the amount of strain. So you have noticed that delta L over initial L is the amount of strain for the case of the first one, elasticity in length. You have find an identical one, delta X over H. You have find that over here, because the product is the same dimension, so the product of strain is dimensionless. It was meter divided with meter, and you would have seen as well for the last one, volume elasticity. It was the same product of delta V over V, and this is actually original V naught, original volume altogether.